Great. Hi, everyone. My name is Matthew. This is also Matthew. It's uncanny, isn't it? If you flip the W over, you get an M. This is my digital twin. We're really excited to be talking to you today about how we use R for geospatial at Mott MacDonald. And some of the talks that we've seen today, have dealt with geospatial data, and typically the response that people get when we say geospatial is like, "Oh, what's that?" So Matt and I are going to try to convince you that it's not the case. And Matt and I are both GIS consultants at Mott MacDonald. And I joined the business fairly recently, in August of last year. And one of the most difficult things about my job that I found was actually explaining to other people what GIS actually means. And in my first 2 weeks, I heard some very interesting interpretations of GIS. Certainly does not mean great internet speeds. GIS, in fact, stands for Geographic Information Systems and Science.
So, yeah, this is what we're going to be talking about today. I'm very happy to be here and to have spoken to lots of people already. And Matt will be talking about a project that he worked on recently, looking at risk assessment of ash or trees with Ash Dieback. And then I'll talk a bit more about how we use R currently and how we're hoping to use it more in the future. And so for some context, we both work for Mott MacDonald. It's a global engineering, management, and development consultancy. This is our purpose and some fun facts about us. In all our projects, we have a strong focus on social outcomes. And when we achieve that is through digital innovation and embracing digital innovation. Yeah.
Cool. So one of the things that we love to do as geospatial data scientists is asking questions. And we like to ask spatially special questions. Geospatial data concerns itself with three kind of principal questions. We try to investigate what is where, why is it there, and why should we care? And in our sector, almost always there is a geographical component to what we do, whether that is asset management, risk scoring, master planning, or optioneering. And understanding the where is a critical part of the puzzle because it enables us to dissect that relationship between space, place, and the problem at hand. And in many ways, spatial data is special compared to your normal kind of tabular data, for those who are not familiar, because spatial data typically requires visualization on a map first. And by plotting things on a map and investigating, interrogating that, you invite people to ask and interrogate the data in a special way. And this works to our advantage because the majority of the world are actually visual learners. So naturally, showing them something pretty and sexy on a map will invite more thought, analysis, and hopefully invite people to ask more spatially special questions. And
so again, for a bit more context about us and about our team, we work within the digital solutions team, within the buildings and cities unit of our business. And so we support horizontally across the company different projects with GIS, data science, and platform development solutions. Here are some of the projects that we've worked on, and the work is quite a varied kind of workload. So we work on different projects, different kind of geographical contexts, different kinds of clients, different sizes of projects, different domains with different questions, ultimately kind of different spatially special questions to ask of that data. And so in terms of technology, this is a rough look at the kind of technology we use geospatially within our team. And so at the start, we often use traditional desktop GIS software like Esri's ArcGIS suite. That integrates quite nicely with our enterprise GIS, enterprise ArcGIS, enterprise, which we use for things like field maps and web mapping. Our team are big users of software called FME, which is a kind of low-code, visual coding, data integration and transformation tool. And when it comes to interacting programmatically with our data, Python has typically been the kind of go-to language. We use libraries like ArcPy, which integrate quite nicely with all of the ArcGIS stuff we do, and allows us to automate some of those desktop GIS workflows. Matt and I both came out of university as keen R users, and so we saw kind of within our team the kind of questions that we were trying to answer, and have been kind of seeking to increase the use of R within our team, and to, unleash its power to answer some of those spatially special questions.
So one of the really exciting projects that I had the privilege of working on is creating an indicative kind of risk scoring for Ash Dieback trees. And this was a project that was done almost entirely using R. So just for some context, what is Ash Dieback? Well, Ash Dieback is an invasive fungal disease which affects trees of the ash species. And it's becoming more and more prominent of a problem in the UK because of factors like climate change. And a lot of our clients tend to be local authorities and councils, and as a result, a lot of these trees infected with this disease may fall on roadways, carriageways, and public footpaths, etc., for which the councils and local authorities are responsible for. And so one of the other teams, the Intelligent Data Analytics team, had developed a solution where they had strapped a camera apparatus on top of a car and driven along the client's road network. And this camera recorded some footage, which was then fed through a computer vision pipeline, and that produced detections and predictions of trees that are infected with this Ash Dieback disease. And this prediction of the severity of the disease spans from class 1, which is the most healthy type of tree and least likely to display any kind of structural failure, to class 4, which is the most severe category of that disease, and where structural failure is imminent and requires quite frequent monitoring and maintenance. And so what we get is this really rich data set of all these points, which are the predicted Ash Dieback trees along our client's road network. Now, this piece of work that I worked on wanted to understand the potential risk that a tree with this Ash Dieback disease poses for road users. And more importantly, we wanted to help our client understand what is the best management strategy for every pound spent. So we have 4 key aims in this project. The first aim was to provide to really understand the where. We have that existing data set of those tree detections along the client's road network. What else can we do with it to extract insights? So we did some clustering and employed some heat mapping techniques to really drill down on, okay, where are your kind of problem areas in that particular situation? The second component was to conceptualize and understand risk. And so we created an indicative kind of risk score which tried to consider other factors such as the traffic density, traffic speed, the type of road, and the fall area for that particular tree, which is then ranked from 1 to 10, where 10 is the highest category of risk. Now, the last part of this project, and probably the most important part of this project, was actually a stakeholder engagement piece. So previously, our client had to pay to dispose of this, all these diseased trees that they had to remove. But what we had done was we collaborated with arboriculturalists and engaged with the timber supply chain for that area. And we had actually found that there was a big appetite amongst kind of various stakeholders, whether that be community groups, sawmills, etc., that people wanted to do something with that wood. And so as a result, what we wanted to estimate was the carbon with each of these management strategies that we had proposed to the client. So how much would that cost you in terms of carbon emissions, as well as costs. And we tried to capture what we call residual values, how much value you can get back by doing something with that wood instead of paying to dispose of it. A little bit more about the risk scores. So we understand kind of risk in this way. So we have the event, which is any kind of structural failure of that tree, which includes collapse of the tree as well, which is a product of your causes, so what would cause that particular tree to fall down, and your consequences, so what would happen if that tree were to fall down. And so we had to extend that data set of tree points that we already had and include a lot of these different variables. And we used R to do a lot of that data engineering. Now, R offers great packages for working with spatial data. And one of the packages that I really like is Simple Features, or SF. And that integrates really well with packages like tidyverse, where you can kind of pipe objects forward. And that tidyverse way of thinking about data makes data engineering for quite a complex data set very easy and very intuitive. We can translate something that is very complex into something that's quite linear for people to understand. And so, as a result of this, for every tree, we get attributes about the road that it sits on, such as the speed and density of vehicles. We have the fall risk areas, so where that tree is likely to fall relative to the road, and whether or not that road is frequented by pedestrians, as well as the health of that tree, so the severity of the Ash Dieback disease, and that forms kind of a weighted score from 1 to 10. So one of the things that we had done in this project is we leveraged the power of interactivity for spatial data science. And we loved using a package called TMap. And this offered great interactive kind of visualization tools. Especially towards the beginning of this project, a lot of what we were doing was quite experimental and exploratory. So the fact that we could really kind of quickly pull together a visualization like this and just kind of click through our outputs meant that it was really easy for us to get a better understanding of what we were doing. We also leveraged some of the power of our Shiny, so we developed an internal tool to help us understand some of the parameters that we were applying to our risk scoring. So this was something that we had done fairly quickly. It's not the most aesthetic Shiny app that we've seen today, but it has kind of these levers that you can pull, and you can see the effect kind of changing the different parameters on that risk score. We had also built in tree profiles, so those are the buttons that you see on the screen where we can look at, okay, what would happen if we'd had implemented these parameters on a tree in an urban area versus a tree in a rural area, for example. We also use a lot of R Markdown documents to help us produce very quickly the exploratory data analyses in an interactive way. So because of the exploratory and experimental nature of this project, changes were quite a frequent occurrence. So the fact that we could just hit knit on that Markdown document, it would spit out a new one for you with all the kind of histograms and statistical distribution plots made this process much less painful. Now this is my favorite bit. We also use R to automate a lot of tedious tasks. Now, naturally, as the most junior member of my team, I am usually assigned the most manually and labor-intensive tasks, such as collecting addresses of schools from a website. Now, I could have done this by hand if I just kind of clicked through every one, all 999,000 pages, copied and pasted the addresses into an Excel spreadsheet. But I don't have the patience of a saint. We don't have time for that. So web scraping is actually a technique that we can deploy to support the development of these spatial data sets fairly quickly. So using packages like Arvest and kind of the tidyverse approach to data, we can very quickly go from something like this, harvest the elements of that website that we're interested in, compile it into a nice data frame, geocode it, and plot it onto a map. And so what we've tried to show here is that kind of interacting with spatial objects in R is actually not as scary as you think. And integrations with libraries such as Simple Features and tidyverse makes doing things like this very easy and intuitive. And finally, one of the reasons why we love R so much is the interoperability with our existing tech stack. So because a lot of what we do sit in kind of traditional desktop GIS platforms like ArcGIS Pro, so a lot of our deliverables needed to be within kind of our templates and conform to our GIS standards. So we leveraged libraries like ArcGIS Binding, which allowed us to kind of just pipe our whatever outputs that we had done in R straight into ArcGIS, and we can spit out deliverables fairly quickly and easily. So in summary, this Ash Dieback risk project, really what I hope to have shown here is that the exploratory and kind of agile nature of this project meant that a lot of what we're doing is quite experimental. And because changes were such a frequent occurrence, doing things programmatically in R enabled us to kind of, once the change was decided, we could just run it through the code as many times as we needed. R's interactive capabilities also meant that we were able to pull together nice looking kind of visualizations and things that you can kind of click through to inspect your data fairly quickly. And this enabled an enhanced understanding of our results and our methodology as well. And lastly, having this analysis in code form meant that this is reproducible across multiple data sets and across multiple sites.
Thank you very much. Yeah, so hopefully over the course of this talk, Matt's shown how we use R to unlock the power of geospatial. We're aware that we're not the most maybe advanced team or advanced users of R that have spoken today. But yeah, I thought it was good just to present what we've got. And so the key reason that we've been so keen to expand our use of R is its power for working with data and specifically working with geospatial data. It's obviously got an existing ecosystem of libraries built exactly for this kind of work, which we've been able to use, and it means that we were able to use the latest data science approaches without having to implement everything first kind of from scratch ourselves, and then that can all integrate with the existing ecosystem. So among those tools, there are lots of first-class tools for visualization, which is very good when you're working with spatial data. And it means that we're able to cleanly present all of our analyses for our end users or clients. R is also highly interoperable, which means that we're able to use it alongside all of the existing stack that we have, existing approaches we're somewhat tied to, like ArcGIS in this case. And yeah, we can adhere to all those requirements. And then finally, R is free and open source, which kind of from a commercial point of view means that we don't need to justify any costs to the business before we can start using it, start prototyping on smaller projects, and using kind of the latest cutting edge approaches for the work that we do. And also, unlike other software that we use, we're not tied into any existing tech stack, and we're free to use the approach that we want to use. So looking ahead, we are actively on the lookout for how we can, as this figure shows so clearly, how we can improve and expand the use of R within our team. It's been great today to hear all the different things that other people have been doing. Some of it I've understood more than others, but it's all good to hear. And so hopefully we'll be able to go home and bring back some of those learnings. I suppose a key consideration for us at this point is how we can ensure that our work is long-lasting, so that the kind of work we do is not just efficient, but also reproducible, that it's not just one of us writing a script and then that dies on someone's C drive, that it's something that other people can use and take forward in the future. So as part of that, we're looking to develop our enterprise infrastructure for R. We currently have an internal hosting platform for our Shiny apps. That's something that's in development and a kind of expanding capability at the moment. Ultimately, at its heart, Mott MacDonald is an engineering company, which means that lots of the ways, and quite a big company as well, lots of the ways that we do work are kind of inherited from engineering disciplines. Engineering as a whole is becoming more digital by default, gradually, and so there are different software that people are, and approaches that people are comfortable using. And so we're kind of looking to take the best bits of those and marry those with data science approach, or the kind of best practice in data science and in software development.
Thank you all very much. and we'll welcome any questions.